In the last lesson, we learned that the pH of a solution is a measure of the concentration of hydroxide ions. There, that means, with the square brackets, means concentration, or concentration of hydrogen ions in that solution. We learned that as the concentration of hydroxide ions increases, then the pH increases from 7, 8 to 9 to 10, right up to 14. And as the concentration of hydrogen ions increases, then the pH decreases from 6 and down to 1. We learnt that if the pH is 7, then the solution is neutral. That's to say, there's no excess of hydroxide or hydrogen ions in the solution. Now, we learnt that the type of acid or alkali will affect the pH. That's to say, some acids are more able to produce hydrogen ions than others. Sulfuric acid will produce a greater concentration of hydrogen ions than carbonic acid. Likewise, sodium hydroxide will produce a greater concentration of hydroxide ions than sodium bicarbonate. So the pH, or strength of an acid and alkali, will depend on the nature of the substance. But it also depends upon how much water is mixed with that substance. For example, let's suppose we've got here 3 equal measures of caustic soda. Again, the chemical name for caustic soda is sodium hydroxide. Now this is a white crystalline solid, but when we add each of these measures to the beakers, then we will produce an aqueous solution of sodium hydroxide. As a result, we will produce exactly the same number of hydroxide ions in this beaker as we will in this one, as we will in this one, since we're adding exactly the same quantity. Let's represent that symbolically with 10 hydroxide ions. Okay, but since we're adding the same amount, we will also have the same number here. And here. Now, although we have the same number of hydroxide ions, clearly we have different concentrations in each case. The number of hydroxide ions per unit volume in this case is much greater than it is in this case. Although we have 3 solutions there, all of these solutions would be called aqueous solutions of sodium hydroxide. Their pH will be different because the concentration of hydrogen ions in each case is different. So we would expect, for example, the pH of this solution to be highest. Let's say, and this is qualitative, okay, let's just say this has a pH of 12, then this may have a pH of 11, and this may have a pH of 10, since there are different, since it has a lower concentration. So we can decrease the strength of an acid or an alkali simply by adding water to the solution and lowering the concentration of hydroxide ions in the solution.